the last part of the lesson, we're going to talk about how to graph a hyperbola. And again, we're just going to review how to find the domain and range from the graph. So to graph, we need to know the center. Okay, so again, we need the center, the direction, A, B, A and B. Okay. All right, so for this problem, we know that it's going to be horizontal because our x is positive. And we know that the center is -3, -2. A is always the first number, so the square root of 49 is 7. And the square root of 25 is 5, so that means B is 5. Okay, so when I make my graph, just because I don't have a ton of space here, I'm going to make a scale of 2. And let's see, so our center is, we're going left 3, down 2, so we're going to need more in our third quadrant. So let's see here. So something like that. All right, so again, if we count by 2's, for both x and y, so I'm just going to make a little note. So scale equals 2. So let's see. So 2 halfway in between is 3, and then down 2. So here's our center. Nope, I might not have left enough room up there for myself, but we'll just make it work. So horizontal, so we're going left and right. So that means we're going left and right 7. So 2, 4, 6, one more is 7. So there's my vertice. And again, if you want, if it helps, you can label these two. So I'm going to just put a V there. And then we're going, so 2, 4, 6, one more is 7. So again, that's my vertice. And then we're going to graph our B value from the center. Okay, so 2, 4, halfway is 5. So I'm just going to put a point there. And then from the center, we're going to go up 5. So 2, 4, 5. And then what we want to do is we actually want to make a box that goes through all 4 of those points. Okay. So we want to make it dotted. So this is not actually part of our hyperbola, but it's going to make it easy to graph by hand. So once we have that, then we're going to connect the corners of our boxes. So that's going to give us the asymptotes. So again, I'm just going to make these dotted lines. So again, we're connecting both corners, and that should go through the center. So now that we have that, we're just going to do kind of a rough sketch of our hyperbola. So it's going to go through the vertex, and again, it's going to follow these lines and kind of curve around. So it's going to look something like this on both sides. Okay. So it's going to kind of start here, curve through the vertice, and then curve around to follow the other side of that asymptote. Same thing, so I'm going to start here, go through the vertice, curves around. So again, this is just kind of a rough sketch of our hyperbola. So the green part that I just drew, that's the hyperbola itself. Okay. So now if we go back and answer domain and range, so the domain is coming from -infinity to this vertex, which is at, let's see, 2, 4, 6, 8, 10 for the x's, so -10. And then it's jumping over to this vertex, so that's at 2, 4 for the x, to a positive infinity. And then the range is going to be all real numbers. All right, the next one, same idea. So this one is not in the form that we need it to be in, though, so I'm actually going to start by dividing everything by 16. So the equation that we want to graph is going to be y minus 3 squared over 16 minus x squared over 16 equals 1. Okay. So since y is positive, this is going to be vertical. The center is at 0, 3. So again, h is always with x, so since there isn't a parenthesis, it's 0. And then k is always with y. A is going to be the square root of 16, so 4. And then b is also the square root of 16. So a and b are the same, which can happen, so that's okay if that happens. And then now we are going to graph. All right, so for our center, since that's in the middle, we're going to go 0 up 3. I'm going to leave a little bit more space up here. So that should be good enough. So again, vertices, so center starting with, so 0, 1, 2, 3. So C for center. And then since it's vertical from the center, we're going to go up and down A, which is 4. So 1, 2, 3, 1, 2, 3, 4. Then 1, 2, 3, 4 for the 2 vertices. So again, if it helps, you can label those. I need to extend this. And then the conjugate axis is what we're going to graph next. So that is going to go left and right from the center. And again, our B value, which is the same as our A, so 4. 1, 2, 3, 4. 1, 2, 3, 4. And then we're going to make that little box to connect the vertices and the conjugate axis. Okay. And then we connect the corners of our box. And again, I'm doing all of this in dotted lines because this is not actually a part of the graph, so it should be in dotted lines. Okay. And then this time it's going to open up and down. So again, it's going to follow our asymptotes, curve through the vertice, and then back around. So it's going to look something like this. And then same thing, so it's going to start up here, go through the vertex, and then back around. So again, the green part, that's our actual hyperbola. Everything else is just to help us get that sketch. So this time, the domain of this is going to be all real numbers. And then the range is coming up from negative infinity to our vertice, and we need the y value at this point, so that's going to be -1. And then we go up to our next vertice, so let's see, let's count. So that points at 1, 2, 3, 4, 5, 6, 7, and then up to positive infinity. All right, in the last example, before we can graph it, we are going to need to switch forms. So since this one's a little bit more involved, I'm going to pause the video here and I'm going to finish this last problem for this section in the next video.